terms of an interval. You said from what x value to where is the function increasing? Where does it start going up? At what x value?
1.
Just the x values.
1.
And when does it stop going up? Doesn't, so what would you put here? Now, when is the function decreasing? So, Jared, what would you say there? Negative infinity out to 1. As x goes out to negative infinity, what does f of x go to? Ken, what would you say? Yeah, it's going to rise up. Describe the right end behavior. Now, this one you're going to have to give out a full sentence on. Evan, what would that sentence look like for the right end behavior? Now, you could say y. What else could you say besides y in this case? Yeah, f of x also works. Either one. Do we have questions on there? All right. We're actually going to hopefully show something that's kind of quick today. It actually worked out. Did any of you take, who's in physics here? Anyone? Did you guys do the pumpkin thing today? You did? Okay. Some people, did you do it? Now, from what I understand now, you'd have to like not use force or electricity or something like that. Is that right? Okay. You have to, okay. So, and you got to get it to move. Did you guys get it to move far? How did you, what machine did you use?
A yoga ball.
Yoga ball?
Yoga ball.
Okay. So the thing that I thought was kind of funny was I went down to Miss Metz. We have a student that we share, so I have to constantly go down and see her. And today was the pumpkin chunking, I think it's called, or pumpkin chucking or something like that. Pumpkin chunking is like a big festival. We'll show you something cool at the, maybe this last 5 minutes or so. But you can go through and like throw them out. And she said like a lot of people use, what was, because I thought everyone used like a catapult type thing.
Like, that's ideally, that's
Yeah, because that's the most optimum one.
Yeah.
And I was like, oh, so did you get a lot of those? I'm like, that must be awkward. Like you're wheeling out all of this like heavy artillery. And she goes, no, a lot of kids just use an exercise ball. And I was like, yeah. That's not going to have as much force though as like flinging it by. Like the goal is to get it to go, right? Like what now? What do you do? Drop it with it on top of it and see how far it goes?
Yeah, you're supposed to like drop it at an angle. So it just goes.
Okay. So I don't know. Did you decorate your pumpkin? No, I heard that that was a thing too. If you decorate it, you can still get 100. Okay. Did you decorate your pumpkins? Okay. Did you buy them decorated or did you decorate them yourself? Okay. Some of the kids were talking, apparently, and Cal kids said that they bought theirs. That's literally the opposite of the point. We're going to go through and take today, do two things. You actually kind of already know how to do both of them, so I don't think it's going to be that much of a strain. We're going to start off with talking about quadratic regressions. If you go through, a quadratic regression is going to take a bunch of data, and if the data fits a quadratic pattern, we can give an approximation to what it's doing. You can use that to predict future or other values. That's pretty much it. The calculator does all the work. So if you're not signed into your calculator yet, there's no hope for you. I don't know what to think. I mean, we say it 100 times. First thing up, we need to go through and give this out. It's given by that data. Now we've got some questions to start. You need to create a scatter plot. Does it appear to be linear or quadratic? First thing up, I'm going to go in, get my new document. I'm going to go right to a working screen. Get yourselves, please, a new doc. So go home, new doc. And on there, we're going to need to enter our data. So it's going to be a listen spreadsheet, which is 4. And now you're going to just start inputting the data. Go in and give the header for the A, the header for the B. And in this case, it's like time and birds or something like that. Or temperature and birds. As we're doing this out, we don't spend a lot of time going over all the different kinds of regressions. The reason being, if you can take one, you can take them all. They're all in the same menu. And if you don't know, I guess, what the question's at, and the question 9 times out of 10 will say, take this type of regression. So raise your hand if you've got this data input so far. All right, next thing up that we need to do on that first question, does it say give out the regression right away, or does it want you to look at the scatter plot first? Okay, so now if I want to look at what this looks like, I would go in and add a page. Remember that pink red one for visualizations? I think it's 5. Yeah, data and statistics. Now, what are you going to want to put along the x-axis? What's your x-axis going to be? Temperature. And then the y-axis is going to be birds. So now you've got something that looks like that. Now, there's really 2 different ways you could view this. This could be quadratic, or it actually kind of, even from that, it looks more like what? Looks like an absolute value graph. Yeah, the one that's like a V. This would kind of look like one of those. Let's see what it says. Does this appear to be linear or quadratic? Well, I don't know how they teach drawing lines in geometry or over at Sprague, but if that looks, who thinks that that looks like a line? Very good. Because how do you know it's not a line? What do lines not do? Yeah, it doesn't bend. So I'd say that's kind of mostly quadratic. Determine the parabola of best fit. Round your coefficients to the hundredths. Now, there's actually 2 ways to go through and take your regression. I'm going to show you both now. Go over, please, to your calc. Go back over to 1-1. So click back to 1-1, however you make that happen. Now, who's at 1-1 right now? Okay, who wants to take a guess as to how we can get to the quadratic regression? Start off with menu. Probably going to go down to, let's try statistics. Maybe we'll see something in there. Stat calculations. Go over to stat calculations. Oh, did you find a quadratic regression there? Yeah, so if you need to in the margin, write that down. Go ahead and do so. That it is menu. We went down to statistics, stat calculations, and then this. Hit enter on quad regression. Now it's going to ask you what your x list is and what variable was in our x position. What did we have in the x? Time. So go in and make that adjustment, or temperature. Then the other one's birds. Now we don't have a frequency list, nothing. Drop down and hit OK. Now arrow back up. See how it gives you A, B, and C. Arrow up 1 more, please, or 2 more. See how it tells you this is your quadratic regression. Hover over this, please, and you're going to see it gives you ax squared plus bx plus c with those as its values. So write down your regression, and you're going to round it appropriately. Do that right now. Get your a, b, and c values filled into the equation given appropriately. Nobody heavily been methods. I don't think we have. What's it say? No? All right, so as we're listing this out, you should be able to get to here. What did you give out as your regression? Bree, what did you go through and say? 514 point what? Okay. Is this what we got? Now, this alone, right now, if you have just this on your paper, congratulations, you got 1 out of the 2 points. What needs to be there in order for me to get my second point? It's so trivial. It's so small, but it happens every year. Every single year. Give it a y equals or an f of x equals. Now, did it, by the way, did it tell you to use x and y, or did it define it as t and b or something like that? Did it tell you which variables to use, or did it? It didn't? Okay. Then we can use x and y. And is this rounded correctly? Is it?
Yeah.
Okay. All right. Now, graph it. How could you go in and graph it? You can go in and graph it on your own. That's fine. Next piece up after that. Based on your model, how many birds rounded to the nearest whole number will be in the preserve when the temperature is? So let's start off and let's try to predict the number of birds when it's 85. Now, it said using that regression model, you need to use the regression equation, and you're going to plug in an 85. What is the 85 going in for? The x, that's your temperature. Now, before you go right to that calculator, let's be unequivocally clear. The work you need to show for this, because you don't have to do any thought, is going to be as follows. You will have to show on your paper, to get the credit, you would have to show group copy no, C. You will show this part, except where the x is, guess what you're going to put? An 85. So on your paper, if this is not shown, when you're doing our work, I don't bother looking at the answer, because you're not going to get the credit anyway. So show the replacement in. Now, we also went over last time how to make this sort of like bumper bowling. How could I get y of 85 the fastest? Yeah, let's define it as a function and then just plug in. So let's do it out as define. And I don't know, go in, type in define. They typed it in as r of x. Let's work with it. So plug in whatever you want. They picked r of x probably for regression, and that's completely fine. It was an x squared, and then some change. Whatever we got for those values, plug in as your r of x. So hit enter there. Now, we needed to evaluate that out of what, 85? Was that what the temperature was? Okay, so evaluate r of 85. Now, what did we want that rounded to? Did it say or no? Here's what? Whole number, so that would be 146. So go over to your calc and you'd write out 146 birds. Next one up, we're going to evaluate out, and on your paper, show out the substitution in. You're going to plug in and evaluate out how many there would be when there were 30, or when it was 30 degrees. So show me the equation, plug it in, evaluate out r of 30. What value should you go through and get there? Haley, let us know what you get when you get it. 78, is that what we got? Yes or no? No? And go to R of 30. Yeah, R of 30 should give you, what did you, hang on. Where are you on here? Do you see yours? Where are you? Bottom, middle, there we go. Now, let's see. R of 30, you know what my guess is? See this?
Oh, I did that.
Okay? So if you go through and that first piece isn't right, the other parts won't be. What did we get for a value out there? Let's be careful at how we would answer out B. Hands up, please, when you can tell me the answer that you would give for question B? Hands up, please, when you can tell me the answer you would give for question B. This is not a difficult, hopefully not a difficult response. Ellen, what do you want to say? Why would you say 0? The calculator spit out like negative 100 and some odd change. Why would you say 0? Yeah, it would be kind of awkward. Like that would mean, hey, not only do we not have any birds around here, but I need you to go over to this other neighborhood and take care of 100 of their birds too. Is that a good idea? Now, and actually this, there is something that's kind of humorous about this. Do you guys do biology class yet? Have you taken like I don't even think it's a living environment, like an ecosystem thing? One of the things that's fascinating is down in the South Pacific, like where Fiji is, they have birds there that you will not find any other place on Earth. And that happened because they were geographically isolated for, at least 10 to 20,000 years, substantially more than that in reality. So when they're alone, they sort of become these really exotic birds that are only, though, found in that area. And then people, though, started coming there, and not people who were like there since humans started settling the Earth. People that are coming there like as part of like a resort or for a vacation, and they all bring with them something. Bring with them, at least the really well-to-do ones, bring with them cats, which are way worse than a nuclear explosion, and it's not to be facetious. They're worse than a nuclear reactor melting down or wildlife. Imagine you throw a cat in an island with a bunch of birds that are gigantic and have no idea of what the hell a cat is. Do they stand much of a chance? No. Like those birds see that cat and they're like, oh, you're like everything else I've seen, and they sort of turn around and then they get picked up. But then what happens to the cats? Well, if you've got a lot of food, what happens to the population of predators? Goes up. Because they've got a lot of food, there's more room to multiply. And then what happens to the birds? Decrease. And is there anything besides people that would stop the population going to 0? Not really. Like they can fly away, but then how many birds are on the island? None. And is that bird going to be successful? Like imagine a bird from Fiji flies over to Seattle. Okay? Is that bird going to be that successful? Are a lot of birds from tropical climates going to adjust well to a Canadian atmosphere? Not so much. So they end up dying. Based on the model, what range of temperatures will there be more than 150 birds? This is such a good one for the calc. You need to find from where to where is our population of the birds going to be 150 or sorry, just more than 150. So I guess I'd say I need my population to be greater than 150. This is just me outlining what I have to do for the question. How do I find a population of birds? Holy cow. What is it? Yeah, it's whatever. Now, in our case, what was it? It was negative, what, point? Oh, we came up with the regression, right? So it's like 0.11 x squared. And what was the second half? 1712. And then 5, is it 518? 0.82. Okay, so. And it's minus which one? This one? Okay. So now we need to figure out the answers to this. And I don't know why you all, maybe it's how they teach algebra. They teach you to get married to algebra. I mean, married to it. You don't need to be that much with these calculators. You'll need it for our work here, but they should have been showing you multiple ways to use this for years. We've got this great big giant equation, and we need to find out when it's bigger than 150. All you got to do is use your eyes and the calc. Go in, plug that in Y1, plug that in Y2. That's it. Go into your calc, get yourself a brand new document. You don't want to work, the other stuff is in there sort of polluting it. I don't want you to. You can add a problem, I guess, if you want to go to 2.1 instead of a brand new one. Go in and get yourself a graphing doc, and in Y1 you plug in the left half, and y2 you plug in the right. That's it. Take about 30 seconds. You've got your y1 and your y2. You're trying to find when the one equation is bigger than the other, or more than 150. And then we'll problem solve once we get to what the graph is showing you. Go in, type in exactly what you had, and it's the same stuff that was on your papers. Now, arrow back up. Did you? Oh, okay. Now, this one's going to be a bit off. Hang on. Go, whoever this is, go please to arrow up. There's too many documents happening here. Guys, just stick to the one document. So, as of right now, your graph should actually look like this once you input both of them. Why would your graph look like that when you input both of them? Your scale isn't big enough. How high do you want to make it go up on the y-axis? How high do we want to make it go up on the y-axis? Look at the equations. How high up do you want it to go on the y-axis minimally? 150 is the lowest possible value you would even go. Let's try like 400. You need to change it, change it. And don't hit enter, hit tab. That lets you cycle all the way around. No, go back up to, now you're going to have to go all the way up to the top. Hit enter on that. So you go back to how it was so you could edit it. Now hit tab. One that says tab on the side. So X max. How high do we want to go on the X-axis? Now, 500 would be a bit unreasonable. Why would 500 be slightly unreasonable? Yeah, at 500 degrees, the birds actually come out very similar to what you would get if you had stopped on your way home and went to Kentucky Fried Chicken. Let's try 150 and see how it goes. How about our Y min? Well, what's the lowest number of birds you can have? Very good. So hit, oh, and then we tab, this I can even say is adequate. Adequate. I want to change one little part though, because your job is to tell me when this is above one. Oh, this isn't even the right equation though, is it? Whoever this is, please press tab. Hang on, please hit tab. Nope, sorry, when you're on this, I need you to get to where this equation is, because this equation is not correct. Go in, please, and no, just click on the graph. It's somewhere in this area, off of whatever you had. Click. Literally, can you just get away from anything? Go to this white zone up here. See that white? All right, click on that. That should help you off-select anything. Now, if you press tab, that's how you get to your equation. So now arrow back up to F1. That is that right or wrong? That's right. So now, if this region here is where it's above, see how we can't see it all that well? Let's make a slight modification to allow us to see it well. What needs to get done for me to see this a little bit clearer? Not a zoom, but yeah. Yeah, lower the Y max. So let's make our Y max, what was it, at 400? Let's change it to like 200. This is the part where you're doing some analysis. So again, get out of this, go change that up to 200, please. And now when we do that, what you're going to see is after that gets changed, you should see that there's this wedge where you're above 150. And even now, it's not that pronounced. And is yours on your paper, is it this small too? I just want to make sure there's nothing wrong with this graph. I thought it used to be a bigger one, but I could be wrong. Maybe it's our Y scale that's a little bit off. In any event, I need to figure out when it goes above and when it goes below 150. How would you find out when it goes above 150? What do you need to find? Yeah, the intersection. There's only so many things we can ask you to do. You've got to find your intersection point. So go in. No, I stay out of this one because you'd have to do them one at a time. Go down to geometry. Then click points and lines intersection points. And you're going to want to click on each of the graphs and avoid the intersection points. You don't want to be on the points. When it says select a graph, don't click the most polluted area. Because now we don't know which graph we selected, and we've got to keep going back up to the top. So if you're going to select, it looks like then you pick the blue one, go over here and get the red one. When I'm asking you to select the graphs, though, don't go to the busy part. It would be like if I walked in and I said, hey, you, come here. How many hey yous are in the room right now? I think 23 of you. Okay, so it's a little bit awkward. Now, when's the first time that we have the number of birds is more than 150? When's the first time that that happens? Oh. You hover over it and hit one of the buttons. I can't remember. It's one of the ones on the inside. Hold it down. Sure. When is the first time that our population is above 150? No, this isn't going to work. You're messing. You grab the grass. If you got a question, don't distract other people. What is it? 74.4. When is the other one? Oh my God. Holy cow. So, if you can't pull it, just try looking. What X value was the first one it went over? You said 74.4. When did it go under? 81.3. The work you would show on your graph looks like this. So you would sketch out some parabola like this and this. You've got points here. We said this one was 70. I'm sorry, I forgot. 74.8 or something. 74.4 and change. And then this one was, the Y value was what? I want to say 84, but I think that was rounded. 81.3 and change. So when did the temperature, for what values of it, was our population more than 150? The nearest 10th, for what temperatures? Rounded to the nearest 10th, is it more than 150? So, Cassie, what would you say? To 81.3 degrees. Now, Michael, what was your question? Did you have one? Okay.
It's asking when it'll be more than 150. So you're doing it, so it has to be like.
It's got to be in between those values, and if you were giving it as an interval, you would not include them. I would say this is adequate. Like, I guess you'd say for what interval were there more than 150 or something. If we were all that concerned about using brackets instead of parentheses or vice versa, or not including those values, I would give it out as an interval or something like that. So according to what you're saying, if you want, you could list it out like this. 74.4-ish is less than T, which would be less than 81.3-ish. Okay? That avoids including those values, because that's when it equals 150. All right? Questions on that? Oh, so this one came up. This is what the launch angles. There's a word comment. Yeah. So we won't do this one out. You would need to go through, in order to do this question out, you would need to take a quadratic regression. Do you know how to take a quadratic regression? Yes or no? Yes. When it goes through now and asks about best fitting rounding, which one will produce the furthest distance? How could you figure out which angle would produce the furthest distance on them? Well, you're trying to figure out your graph. You get a quadratic regression. Along the x-axis is your angle, and the y-axis is your height. How do you find when that maximizes? You find a vertex. Next one up where it's 450, you'd set it equal to 450, and graph them out, find the intersection between them. I don't think there's only so much that we can do with these. I think it's the same pretty much over and over. This will be, I guess, we'll have this be our last one. Go through, please, and read out number 3. Do out A and B. Make sure you read the prompt. before we get too invested in this, some of you will input what's on the board and get an incorrect answer. Notice what I just said. You're going to input what's on the board, and you're going to get an incorrect answer. Why? Take a look at what's there. Why? If someone inputs what's up there, why would they be wrong? The reason I'm asking you to stop now, some of you are aimlessly just following through no matter how many warnings you get. You got 4 or 5 of us. You input what's up there, you will get the question wrong.
This is the right 1960 1970.
So this is 10, this would be 20, this is 30, this is 40. Now it wants you to then do some analysis in B. Your approach to B might be slightly different. Again, I'd rather you get it right than not. Who's got what the model is? Do we have anyone who has our regression yet? Another minute. Andrew, how many spots do you want people to round to? Hundreds? All right. What would you go through and get, Kylie, when you round that out to the hundredth spot? Is this what we have? Great. How would you answer out the B part of this question now? You know what you would do? Take a minute, read what's there for the B half.
Plug in 35.
This is good. What did she not do that there might be some of us who still, even after the prompting, what error am I anticipating seeing frequently? Yeah. Yeah, you want to go through and say y is equal to 0.02 times 35 squared. They've got to use the right ear, 0.91 times 35 minus 2.09. What does that work out to be? Did anybody get an answer for that? No answers yet? Did not exist. One person. And John, how many spots do you want this person to round to after the decimal? 2? All right. Raina, did you get a value? What do you got? 54.36%? 26? Questions on that? Hmm. 10 minutes. We'll give it a try. Let's do, yeah. Oh.
Oh, I don't even know. I heard it.
Is that all right? Did I do anything? Is that the right answer? Okay. Was your question about just the percent? So, the good and the bad. Well, take out your Chromebooks. We'll give you guys. I'm sorry it went this long. I didn't think it was supposed to, but the good news is. Was not even good news. Let's see. We got one, two. So I'm going to need 22 of you signed in. I think these ones, though, by and large, are pretty quick. These are just on polynomial stuff. We're going, we won't be able to go until all of you are ready. So if you're going to be the person that makes us all wait, hey, you're the person. We're at 9, 12. I think we need minimum will be 1, 2, 3, 4, 5, 6. We need 22. We'll get through one round at least. One. We're still waiting on 3 of us. 2, 1. Otherwise, you're boxed out. 3, 2. Okay, get with your people, please. We'll have you move around quick. Remember, one of you will have the answer. Discuss with each other. We'll have you get started now.
I don't know this. Oh, it's a good definition.
Oh, some of them have pictures, sorry, on the side of what's a factor on the left.
I trust you. Equation number 10. Oh, well, it was the. No, it was pretty bad. I saw this
What?
It's fine. Okay, that one is horizontal. Guys, this is so bad. P is negative. I think I don't have. What do you say?
Oh, the directrix of a horizontal. Horizontal, there you go. And the X will go up and down. Wait, what? If you're paraboling from side to side, right? Where's the directrix going? Up and down, so it's an X line.
Oh yeah, that one's Y squared. They're like opposite. It's up and down. Oh my god! No, X squared. No, it's okay.
Wow. Oh, there's a negative value there? Wow. All right. We'll give you one more try. We've got another minute or two. You can fit one more in.
We got this.
It's right there.
Oh, we're.
If you get one that says factor, look to the left.
Oh, that's the. That's would be Y. That's gonna be Y squared.
I don't have it.
So you're open. Oh, you were?
Set of
And a positive feedback. And then 4 keys, positive and not negative. Do you have it?
Wait, I don't know. Wait, just do it. I know she was right the first time.
What are you guys?
We're so
You guys need to attack. These are the sharks that penguins are not afraid of these sharks.
What is Oh my god! Oh my god!
All right, congrats. Get back to your seats, guys. Get back to your seats, guys. Now, for our homework tonight, you actually have some practice questions with some answers. I'll tell you this, go to page, we'll do it this way, go to page 16, actually, I'm sorry, page 15, and there are 1, 2, 3 at the bottom on page 15, those 3. Have those 3 questions on the bottom done for your homework, that's it. And the answers to them are right above. So what page? Yep. Have a great day, guys.